What if our universe is not the only one? What if everything we know, stars, galaxies, even the laws of physics, are just a tiny bubble in an unimaginably vast cosmic ocean? This is the core idea behind the multiverse theory, a concept that challenges our deepest assumptions about reality. Far from being pure science fiction, the idea of a multiverse is being taken seriously by physicists, cosmologists, and philosophers alike. In this episode of Infinity Beyond, we dive into the wild world of parallel universes, exploring the science, the speculation, and the staggering implications of infinite realities. What is the multiverse? The word multiverse refers to the hypothetical existence of multiple, possibly infinite, universes. Each of these universes may have its own laws of physics, dimensions, particles, and constants, and may be completely separate from our own. Some may be eerily similar, differing only in the outcome of a single event. Others could be so foreign that time, matter, and logic behave in ways we can't even imagine. In essence, the multiverse theory suggests that our universe is just one of many, perhaps one of infinitely many. Level 1. Infinite universe. The simplest form of multiverse starts right within our own Big Bang model. If the universe is infinite and space continues forever, then somewhere out there, far beyond the observable universe, there could be regions with identical copies of you. This idea comes from basic probability. In an infinite space, with a finite number of particles and possible configurations, repetition is inevitable. So, somewhere out there is a version of you watching this video, but wearing a red shirt instead of blue. And another version where Earth never formed, or where dinosaurs never went extinct. This is known as the Level 1 multiverse, infinite space, infinite possibilities. Level 2. Bubble universes. According to inflationary theory, shortly after the Big Bang, space underwent a rapid expansion, faster than the speed of light. Some versions of inflation suggest that this expansion never fully stopped. Instead, it continues in most regions, occasionally creating bubbles that stop inflating and form individual universes, like ours. Each bubble is a separate universe with its own physical constants. This leads to the Level 2 multiverse, where universes form like bubbles in a cosmic foam, each with different laws of physics. Our universe might be just one bubble in a vast foaming multiverse. Level 3. The Many Worlds Interpretation. Now we enter the quantum realm. The Many Worlds interpretation of quantum mechanics suggests that every quantum event, every time a particle has multiple possible outcomes, all of them actually happen, but in separate branches of reality. This means that with every decision, every roll of the dice, every fluctuation, the universe splits into parallel worlds. This is the Level 3 multiverse, where an infinite number of yous live out every possible outcome of every choice you've ever made. In one world, you became a scientist. In another, an artist. In yet another, you never existed at all. It's a multiverse branching from your own life, constantly. Level 4. Mathematical universes. The most abstract version is the Level 4 multiverse, proposed by physicist Max Tegmark. This theory suggests that all mathematically possible universes exist, not just variations of physics, but variations of logic, structure, and reality itself. In this model, the universe isn't made of matter, but of math. Every consistent mathematical structure corresponds to a universe. Some may resemble ours. Others may be completely unrecognizable. This is the most expansive and controversial version of the multiverse. But it also reflects a deep question. Is math invented by humans or discovered? Because it's the fabric of reality, evidence, and challenges. Here's the tricky part. We can't currently observe other universes. By definition, they're beyond our observable horizon, or completely disconnected from our space-time fabric. Still, several pieces of indirect evidence keep the multiverse hypothesis alive. Cosmic microwave background. Tiny anomalies might hint at collisions with other bubble universes. Fine-tuning. Our universe's physical constants are precisely calibrated for life. A multiverse provides a natural explanation. We exist in a universe where conditions allow observers to exist. Mathematical elegance. Some models of physics, like string theory, predict a multiverse naturally. But the main criticism is falsifiability. If we can't test it, is it science? Some argue that without direct evidence, the multiverse remains philosophy, not physics. Philosophical implications. If the multiverse is real, it changes everything. It challenges the uniqueness of our universe, our planet, even ourselves. It means that every possibility is played out somewhere. Every version of history, every alternate timeline, they all exist, with their own observers, stars, and questions. It also raises ethical and existential questions. If every choice creates a new universe, does free will exist? If every tragedy happens somewhere, how do we find meaning? If nothing is truly unique, what matters most? The multiverse forces us to look beyond the visible and confront the infinite. Final thought. Whether it's a cosmic foam of universes, infinite quantum branches, or math-born realities, the multiverse idea is more than just a wild theory. It's a mirror of imagination and a test of humility. Because if our universe is just one of countless others, then the cosmos is far stranger and far grander than we ever imagined. Here on Infinity Beyond, we're not just peering into the stars, we're peering into every possible version of them. And the only question left is, which universe are you in right now?